Hi everyone, my name is Lydia and this is what I wish that taught me about econometrics and introduction. In the previous video, we ran IV estimation using the CARD dataset, and we noticed that the OLS and IV gave similar estimates. Now we're going to test that formally using the Hausmann test and see what it looks like when OLS is probably fine. So in this case scenario, we're going to see the case when OLS and IV very likely tell the same story, but in the next video, we're also going to see another scenario where the OLS and the IV estimations clearly tell us a different story. So without further ado, let's switch to R. As usual, we're going to load first the CARD dataset, and although we've done this in the previous video, I'm just going to show you once again. We're going to run both the OLS and the IV. In this case, we're just going to go straight with the IV reg instead of doing the manual work. So we're going to use the IV reg where we have our usual structural equation, but also then the equation that would have been in your first stage for the IV. So we're going to just run this and remind ourselves once again of the results that we found. So we had an OLS coefficient that is 0.074, while the IV one is 0.1323, with a difference of 0.058. For the Hausmann test, we can run that via the IV reg diagnostics. So what we would need is, first of all, the summary from the IV, and we can use the diagnostics function in here from the IV summary to get all of the information that we need in terms of like either the p-value or the statistic. I'm just rounding the numbers in here, so that should be okay. As a reminder, for some of you, it might be a little bit weird for me to say like, well, hey, look, these look quite similar in terms of numbers to each other, because there is a difference of 0.05 and clearly this is 0.1. Well, this is 0.07. However, the question is not as much as like, do they look similar or not, to as much as, well, are they statistically similar or are they statistically different? Okay, so that's why we're going to use the Hausmann test to really see how are they statistically different or not. Now, adding the diagnostics in here, the way that we're doing it, equal to true to the summary, gives 3 tests automatically. So it gives the weak instrument, which tests the first stage strength. It gives you the Wu-Hausmann test on endogeneity, and it also gives you the Sargan tests of over-identification, and that is only when you have over-identification. So let's read basically each and every one of those. So the moment that we had this print, as you can see, there's a lot of other code that it's showing in here. So you've got the diagnostic test, weak instrument, Wu-Hausmann, or the Sargan test. For the Sargan test in here, you can see like not applicable, and that is because this is not an over-identified model, because we only have one instrumental variable for the suspected one endogenous variable. If we summarize all of that information a little bit more nicely so that we can see only the values that we are interested in having, we're going to see that for the F statistic of the first stage, we've got a value of 16.718, which clearly is bigger than our rule of thumb 10. So distance is a strong instrument, and the instrument here has passed the relevance check. We have then weak instrument p-value 0. Again, this means that we would have rejected the null hypothesis that it was a weak instrument for this Hausmann-Wu test. And then normally for the Hausmann-Wu, now you would have the null hypothesis that education is exogenous, meaning OLS is consistent, or the alternative that education is endogenous, which means that you prefer the IV. And the Hausmann test statistic here is 1.539. So for any of you who might be confused and asking like, well, which table should I really look up for a critical value, don't worry, because you can just simply look at the p-value, which is what most people do. And the p-value is 0.2149 in here, which is a lot bigger than your, let's say, benchmark of 5%. So here you clearly fail to reject the null hypothesis where education is exogenous, which means that OLS in this case seems to be consistent, and OLS and IV are not really significantly different from one another, which means that if you refer to our table of comparing OLS and IV, and when we prefer to use one or the other, in the case where we have exogeneity, we would prefer to use the OLS for efficiency, because otherwise we're going to have like some lost variation because you're using basically the instrumental variable. You can also do a manual Wu-Hausmann test if you want, as like a way to check for yourself and to make the test more transparent. In that particular case, what you would have to do is run the first stage residuals and ultimately get the residuals of the first stage and then include the residuals in the actual structural equation, which is what happens here in step 5, the visual comparison, okay? Or step 6, where you actually do all of the steps one after the other. Okay, so the first stage, education, we've got distance being included, and then for the step 2, we've got weight on education and V hat, which is the residuals out of the first stage. If we look at the summary of this, we're going to see here education, the same coefficient that we had expected out of the IV regression as well. In terms of like comparing in the end the actual values, these coefficient, like this difference of that minus 0.058 has a p-value of 0.2149, which is exactly the values that we found earlier directly with the diagnostics option. So what are the key takeaways in here? In the CARD dataset, the OLS and IV, they give similar estimates. Now, the Wu-Hausmann test fails to reject, the weak instrument test passes, which in conclusion means that OLS is probably fine in here, which kind of coincides with the CARD 1995 finding that education may not be as endogenous as feared, and the return to education is similar whether or not we use the instrument. And that is also exactly what Angus and Kruger found too. So sometimes IV's most important contribution is confirming OLS and not really overturning it. When the Hausmann test fails to reject and the instruments are strong, then OLS and IV tell the same story, but you will prefer OLS for its efficiency. In the next video, we'll switch to a different data set where OLS and IV tell different stories and the Hausmann test rejects strongly. So stay tuned and I'll see you then.